Wow, here's a blast from the past. A long, long time ago, when you were so young, you learned 4, 5, or 6 different steps or strategies you could take to evaluate a limit. Some of this might even be fuzzy in your brain. Well, at that point, we said we can't learn about Johnny L'Hopital because Johnny L'Hopital is a dangerous, dangerous man, and we don't even have enough calculus knowledge to use his rule. Well, we now have enough calculus knowledge to use that rule, so let's dig in and let's get a final limit strategy to help us out. To do it, I'm going to start off and use one of your very famous limits, the memory limit. And it turns out you don't necessarily have to memorize it. You know that that answer is 1, but I'm going to show you what Johnny L'Hopital would tell you to do. He would look at this thing and he would plug in the 0 into the sign, plug in the 0 into the x, and say, uh-oh, we've got a problem. That 0 in the denominator blows it up, and so we can't use the plug-in. But Johnny L'Hopital says, hey, try this. Rewrite the limit problem, because you have to do that every step on a limit, and do this. Take that numerator and take the derivative of it. Look at the denominator and take the derivative. Now that's not quotient rule. Quotient rule is a far different thing. It's low d high minus high d low all over denominator squared. But in this case, I just took literally the derivative of the top and the bottom. And through the miracle of Johnny L'Hopital, if I plug in a 0, cosine of 0 is 1. There's nothing to plug into on the bottom. My answer is 1. Johnny L'Hopital gets the answer by taking the derivative of the numerator and the derivative of the denominator. Wow, that makes you wonder why we learned all that other stuff. Well, there's some fine print from the lawyers. First of all, Johnny L'Hopital's rule for the purposes of our course is only going to apply if after we plug in, excuse me, if after a plug-in we get a 0 over a 0, then we're allowed to use Johnny L'Hopital's rule. Or, if we plugged in and happened to get an infinity over an infinity, Johnny L'Hopital also allows us to use his rule. By the way, his name is really not Johnny L'Hopital. I don't know what his first name is, but his last name is L'Hopital. Sometimes they pronounce it La Hospital or something like that, but he's not around, so he's not going to be offended. So let's just call him Johnny L'Hopital. These are the conditions that must exist from the plug-in for you to use Johnny L'Hopital's rule. There's also one more layer of fine print from the lawyers. For the AP test writer to give you full credit, or for your college professor to be proud of you, you must show that you acknowledge the conditions exist to use Johnny L'Hopital's rule. Your instinct is just to scribble a 0 over 0 on the paper, but that doesn't cut it. You have to do this. You said, hey, I did the limit of the numerator and I got a 0. I did the limit of the denominator and I got a 0. Thus, Johnny L'Hopital's rule applies. This has to be on your paper to get full credit for your correct answer. This is for the math lawyers. So let's do one more example of Johnny L'Hopital's rule. And we're going to use the no, this is not famous. The first one was famous. Let me rearrange this. Hold on. Okay, here we go. So we have a not so famous example, and in this case, if I plug in an infinity, which we know we can't really plug it in, the numerator is heading towards infinity, the denominator is heading towards infinity. So L'Hopital's rule applies. Now you may or may not recall, we ran into this dilemma earlier in the year where we said, I wonder what's stronger, e to the x or x squared, because they're both getting huge. So if I wanted to do an intelligent t-chart, as my x is blasted off to infinity, both my numerator and denominator would be heading to infinity. That's a bummer. Some people can figure out which one is stronger. Who cares if you can or you can't, because Johnny L'Hopital's rule comes to the rescue. I need to rewrite the limit, and now when I do the derivative of the numerator, that's an easy derivative, the derivative of the denominator, now we go ahead and plug in infinity. If I plug in infinity, the numerator is huger, infinity, the denominator is also infinity. So L'Hopital's rule did not work. But here's the great thing about L'Hopital's rule. You can use it more than one time. You can use it repeatedly. So for this one, I'd still have to give the lawyers the fine print. The fine print has magically appeared. It basically acknowledges in true math notation that the limit of the numerator and the denominator are both infinity. So I have again an infinity over infinity situation. That's one of the situations where L'Hopital's rule applies. The other is 0 over 0. So L'Hopital's rule says take the derivative of the numerator. Well, that's easy again. Take the derivative of the denominator. Now, as we approach infinity, I get an infinity or a huger number on top. Bottom stays at 2. So my final answer is infinity. Just a little background knowledge. These are the only two conditions that we'll use in this course. There's some other what's called indeterminate forms that you might come across later in your calculus life. It's weird things like infinity to the infinity power, just weird mathematical black holes like that where L'Hopital's rule applies, but the AP test writers only care about these two for us. Now your limit knowledge is complete.